Test 1 review is page 4. Find x and y intercepts of each of the following functions. In part E, we got a function is a fraction. Now we first find y-intercept, and for y-intercept we set x0. So y equals 4 times 0, 0 plus 2, 2 over 0 squared 0. Oh, that's undefined. Okay, that means there are no y-intercepts. So y-intercept none. And for x-intercept, we can have more than one x-intercepts. We set y0. y0 means 0 equals 4x plus 2 over x squared. Now we need to solve this equation for x. So we can write 0 is 0 over 1 and cross multiply. So let me write this way first, because 0 times x squared is 0. So 1 times 4x plus 2, that's 4x plus 2 equals 0. 0 times x squared 0. Now isolate x. Subtract 2 from both sides. Divide by 4. So 2 over 4, which is 1/2. So the only x-intercept in this for this function is negative 1/2, 0. Here h, so in h part, h is given, this is just y. 6 minus x over x squared plus 4. So to find y-intercept x0, so y equals 6 minus 0, 6 over 0 plus 4, 4, that's 3/2. So y-intercept is 3/2. That means we write in this way, x0, y 3/2. Now let's find x-intercepts. For we put y0, so left hand side y0 equals 6 minus x over x squared plus 4. Now we can write 0 as 0 over 1. Now we cross multiply. It's 0. This part is 6 minus x is 0. So negative x, so add x to the both sides. So 6 equals x, so x equals 6. So there is only one x-intercept, which is 6, 0. Okay, let's move to G here. Let's find y-intercept. For we said x0, so y equals, this is 5, absolute value 5 minus 0, just 5 plus 1. Absolute value of 5 is 5 plus 1, 6. So y-intercept is in fact 0, 6. And x-intercept, we need to take y0, so left hand side is 0 equals absolute 5 minus x plus 1. Now we need to solve this equation for x. Subtract 1 from both sides, we get negative 1 equals absolute 5 minus x. Now you want to be careful. Look at absolute value of anything is always positive number or 0. So absolute value of anything cannot be negative number. So there are no x values for which absolute value of this is negative 1. Because absolute value means distance from the origin or from 0, that is always 0 or positive, so can't be negative. So no solution. So we cannot solve this. That means x-intercept none. No x-intercepts. That means the graph of the function does not intersect x-axis. Here in H, we do the same thing. For y-intercept, we said x0, so this is y, by the way. So y equals 5 minus 2 times 0 is 0 plus 3 is 3, and the absolute value of 3 is 3. 5 minus 3 is 2. So y-intercept 0, 2. X-intercepts, we can have more than one. Let's say X-intercepts, we take y0. So left hand side, y0 equals 5 minus absolute 2x plus 3. Now we need to solve this for x. Okay, so negative absolute value, let me move this over. This negative means add this absolute on both sides. So if we add this term, negative means positive 2x plus 3 equals 5. Or we could have moved 5 to the other side, subtract 5 from both sides, then cancel negative negative, so we get in this way. So we need to solve this equation. So basically here we got absolute value of something equals 5, so that something should be 5 or negative 5. Okay, this implies when we get rid of this, so 2x plus 3 is 5 or negative 5. Okay, it makes sense, right? Absolute value of 5 is 5, absolute value of negative 5 is also 5. So this expression is either 5 or negative 5. Now solve for x. Subtract 3 from both sides, divide by 2. So x equals subtract 3, 5 minus 3, 2, then divide by 2. So this is 1. Here subtract 3. So let me show you. Subtract 3 means negative 5 minus 3, negative 8, divide by 2. So negative 4. That means we got x-intercepts 1, 0, negative 4, 0. Okay. In number 6, sorry. That's on page 5. We need to find domain of each of the following functions. Domain. So we got y equals absolute value 5 minus x plus 1. So we can always find absolute value of any number. So there are no restrictions here. So we need to write the domain in interval notation. So we can plug in any x value, still we get some number. So the domain is all real numbers. So negative infinity through positive infinity. And we never include them. So never use bracket for infinities. Now here we got cube root on the top. So cube root is defined for any number. So this is good. I mean, this is good for all real numbers. So we have no restrictions on the top, from the top. But the bottom, we got a degree 2 polynomial. Bottom cannot be 0, because when we divide by something by 0, that's undefined. So we should not have 3x squared minus 12x 0. So this is not equal to 0, but we would like to see the x values where it is 0. Now we can solve for x. Look at this. These two terms. So let's factor 3x out. X minus 4. Now it's times. So either 3x 0. That means x 0. Because 3x 0 means we can divide by 3. Then x 0. X minus 4 0 means x equals 4. Okay. So 3x 0, we got x 0. X minus 4 0, x equals 4. At 0 and 4, the bottom becomes 0, that is undefined. So in the number line, all real numbers here, by the way, negative infinity through positive infinity, we have to remove 0 and 4. Okay, they are not in the domain. So in the interval notation, negative infinity through 0, 0 is not included. Union 0 to 4, union 4 through infinity. Okay. In part C, 2x, it's always defined. So we got some restriction on the bottom. Bottom cannot be 0. At the same time, we got square root. And we know that square root of non-negative numbers are defined. I mean, this can be 0, but we cannot have negative number. But this is located on the bottom. So located on the bottom means when we have a square root of 0, which is 0, something divided by 0 is undefined. So this should be strictly positive. Okay, so 15x minus 3, which is inside, that can be bigger than or equal to 0 whenever we have a square root. But this is on the bottom, so we cannot have 0. So it has to be 15x minus 3 strictly bigger than 0. From this we can find x, add 3 both sides. Now divide by 15, 3 over 15, that means 1/5. So x bigger than 1/5. So here is number line. So x must be bigger than 1/5. I don't know, 1/5 somewhere, positive number, 1/5 is here, 1/5, and x is strictly bigger than, not including this. So we get parentheses and bigger. Bigger means in the right hand side. So 1/5 and all the way to infinity is the domain. In part D, we have now square root of something on the top. So that is 2x minus 1 on the top. So it has to be bigger than or equal to 0. So we can have 0 on the bottom, no problem. That means add 1 both sides, 2x bigger than or equal to 1, divide by 2. Okay, that is coming from the top. X bigger than or equal to 1/2. From the bottom cannot be 0. So we need to find the x values that make the bottom 0. So here is x squared plus 3x minus 10, 0. Let's factor this quadratic trinomial. So x 5 times 2, 10, to get plus 3 plus 5 minus 2. So this is x plus 5. Okay, this is x plus 5. So from this factor we get x is negative 5. From this factor we get x minus 2, 0 means 2. So x cannot assume these two values because they make the bottom 0. So on the number line, let's look at here, x must be bigger than or equal to 1/2. So 1/2 is somewhere, I don't know, here. So that must be bigger than or equal to 1/2. 1/2 is included and bigger. At the same time, we cannot have x negative 5. So we cannot have negative 5. In fact, this is already excluded because our domain only contains numbers 1/2 and bigger. And there is 2. So 2, there is a hole. We cannot have 2. So the domain is all real numbers bigger than or equal to 1/2, but not including 2. So we start with 1/2 and 2 because we have to exclude 2, to parentheses, union 2 to all the way infinity. So this is the domain. Okay.